Okay, let's start. So our next talk is about the FFV1 ecosystem, done by someone who knows that very well. Please welcome Jérôme.
Hello. A bit sooner, Jean-Baptiste said that we don't speak enough about FFmpeg, so we'll speak about FFmpeg a bit more, but not about a very fancy codecs. The word is about the lossy compression, H.265, VVC, or AV1, but we will speak about something a bit more boring. It is the lossless compression. Because some people need to do some broadcasting and just broadcast and forget the content. People can watch and have a lot of compression artifact. If it is visually lossless, or if visually it is not so high level of artifact, it is fine. But for some other people, having a lossless video coding format is very important. And also something open, so no patents and so on. So FFV1 fits a lot of things about that. It is a very old technology, more than 30 years old technology, so no patent for sure. There is also a good reference encoder and decoder. It is FFmpeg. Thank you, FFmpeg. It is widespread, so a lot of people can use it. We can embed FFV1 in a lot of different containers. The most used are AVI for all people, MP4, Matroska, and MXF also. And FFV1 has a good balance between compression and speed, and also a bit about cost. So, because there is some competition, some open formats also in FFmpeg, they can have a good compression, but they are very slow, or the compression is not so good. And outside of FFmpeg, we have JPEG 1000, 2000, for example, but encoders are pretty expensive sometimes, and so on. But FFV1 is natively in FFmpeg. The compression is good. The speed for a lossless format is not so bad. So we use it a lot in some configurations. Especially because with an open format and an open source implementation, it is easy to expand depending on the need we have. So with FFmpeg, we have only black and white, or YUV, or RGB, and we can also add an alpha channel. We can expand it up to 16 bits per component, so from 8 to 16, and also if we need 12 or 10. We can adapt a lot of the FFV1 format for being able to support every input we need. With the latest development a few years ago, we have also a good multi-thread system in FFV1. We have checksums, so we are sure that when we store the content, we can detect if there is a problem during the storage. A lot of work was done by Michael Niedermeyer a few years ago. So he is the main developer of FFV1. So thank you to him about that. It helped a lot. So we are aware that lossless compression is a very niche market, because not so many people need it compared to the broadcasting, the lossy compression like H.264, H.264 or AV1 and so on. And these people who need that are not rich, but it is pretty important for them to have a lossless compression. And also, actually, it is also for us important, because a lot of users who need lossless compression is work in archives. So for our heritage in 100, 1,000 years, we need to have the content. And for that also, it is important to keep the content as the best possible. So no compression artifacts. It is the reason these people, they want no compression, no lossy compression. And in this niche market from archives, some entities discovered that paying for FFV1 development inside FFmpeg, for example, is a lot less costly than buying products on the shelves. Even if the products are there, when you buy a product, it is pretty expensive. It is a package. You need to buy a package. And actually, if we take this money and don't buy the products on the shelves, and we develop a product inside FFmpeg, it is less costly. And then after that, other entities discovered that, oh, it is in FFmpeg, and it is open, it is free, off charge, no patent. The software is also free, open source and free, and there's a lower cost for them too. So it is very good for these people. They are not Twitch. They need to have this lossless compression, and FFmpeg is perfect for that. But yeah, they need to trust that this choice is sustainable, and FFV1 is in FFmpeg, but it is not a standard. So Archive wanted to have more trust in the format. So it is not only about code, but we need also to have a standard, for example. And there was a work sponsored by the European Union called, and there was a project called Preforma to help Archive to have checks on their file. And for the documents in Archive, it was easy, PDF, it is an ISO standard, fine. For images, when they do scan, it is also not so bad. They have TIFF, it is an ISO standard, it is good. But now they have a lot of AV content, and for that, there was no open and standardized format. So they decided to sponsor some work on Matroska and FFV1 and PCM for the audio, so no format for that. So we tried to work with Preforma, and we helped to create an IETF working group. And why IETF and not ISO or SMPTE is mainly because IETF has no paywall for the standards. So it is very useful for people who are not Twitch. A lot of archives are very small. They don't have the money to pay a lot of different standards and so on. And also, IETF is very welcoming new people, helping them to create a new standard. So thank you to IETF for that. On our side, we focused on different formats, so Matroska for the container part, FFV1 for the video part, and also for some lossless audio compression FLAC. So now with IETF, we are working well. It is a bit slow because we are mostly now volunteers, but we are still working inside the Cellar working group. So Matroska, it is still a work in progress. A part, EBML, the base of Matroska, is already published. It is a RFC, so it is good. Now we are working on the core of Matroska. So it is on the way, and then we will work on the codec, on the tags part, and so on. A lot of work is done by Steve Lom. Thank you to him. And thank you, Steve, you are there. And also for FFV1, we worked on having a standard. So now the version 0, 1, and 3 are published. It is an RFC, so people are more confident in that. And we want to have also FFV1 version 4, but we still need more development about that. About FLAC, the audio part, it is still on the way. There is an IETF last call, so the specification is nearly ready, but there is still some review by IETF to do. So Martin is working a lot on that, and we hope to have the RFC maybe next month. But for video format, it is not only in IETF world, it is not only Matroska. We also need to have it accepted a bit more everywhere. So we asked to SMT to accept FFV1 in MXF. So it is not something easy because SMT, you need to register and you need to pay a lot and so on. But thanks to the Library of Congress, they wanted that to replace JPEG 2000 by FFV1, so they worked with SMPTE, and now FFV1 is officially supported. in MXF. So it is not a standard, but it is a RDD, so registered disclosure document, a bit like ProRes in MXF. We have the universal label from MXF are available for FFV1. It is not a hack. It is registered in XMPTE. So FFV1 is not only in FFmpeg and not only in Matroska. It is also in other containers and not only the one used on the web. It is also used in MXF, so more for broadcasting. FFmpeg has support of FFV1 in MXF for demuxing for the moment, and we sent a patch for the mux on FFmpeg level. So it is on the way to have a good support of FFV1 in MXF inside FFmpeg directly. For the archive, it is not only about storing the files, it is also being sure that the files are perfect compared to the specification. So we work with an ecosystem. So it is not only the code, so we create a file and then we put in the storage. We want to be sure that later it will be readable, because it is not just an immediate usage, it is for the future. So a lot of people need to be sure that the file is fine, so we created a conformance checker called MediaConch. And based on the specification from Matroska and FFV1, for example, we can say that the file is conform or not to the specification. And before putting the file in the storage, we are sure that the file is conform to specification so that it will be easy to read it later. But it is sometimes we have in the archive we have different inputs with very different formats, and so with some proprietary formats sometimes about lossless storage. So for the archive, it is very difficult to be sure that in 100 years they will be able to play a file with a codec only available for Windows 95, for example, and it is only 32 bits, and it is only for Intel CPU, but maybe in 100 years there will be only ARM. So it is better to convert, and for that a lot of people are using FFmpeg. So thank you FFmpeg about that. And archives, the Film Institute and so on, they use FFmpeg. They don't develop FFmpeg, but the community needs also to do some scripts. So they publish scripts about how to use FFmpeg. So we have 2 examples there about how archives are using FFmpeg for doing the transcoding. Another practical usage in film archives is that usually they receive from a scanner DPX files. So they don't have only one file, they have 1 file per image. So it is totally crazy for the file system. And it is difficult to store, it is very huge, there is no compression, and so on. So we can help with open source formats. So with Matroska, FFV1, and FLAC, why not? It's still huge because it is lossless compression. But dividing by 2 the cost of the storage is good to take when you have petabytes of content. The issue is that not all workflows accept FFV1 and Matroska. So we need something for doing the conversion between DPX and FFV1. Yeah, there is also sometimes some legal commitments. It is a bit crazy, but we need to have the exact same file. So if a DPX file comes in, the legal requirement it is to provide the DPX file when it is requested by the state, for example. So for the compression, it is not so good because FFV1 compresses the video, but not the DPX header, for example. So we need a bigger ecosystem than FFV1 alone, because FFV1 is about the video compression, but not everything beside the video content. So we created a tool called RawCooked, and this tool fills the gap between what exists, FFmpeg, and what is needed to save the DPX header, for example. So with RawCooked, we take the DPX header, we store it in an attachment in Matroska, so it is also useful to have an open source content container format because we can expand it and so on very easily. And we send to the video content to FFmpeg. FFmpeg does the compression. And beside that, when we need again the DPX, we decode with FFmpeg, we inject again the DPX header, and we create from that the exact source file. So we have this ecosystem around FFV1, and we want to expand it to have what could we do with that? FFV1 is good, but speed, okay, it is good, but we could be better, maybe. We want to expand the decoder and encoder maybe with SIMT or GPU acceleration, but we need to work on that. And then maybe if we have other needs, we will create FFV1 version 4 and with inside the IETF system. So as a summary, code is important. For example, FFmpeg has a very good encoder, FFV1 encoder and decoder, but it is not enough because we need to make user communicate and to share the scripts. We need to have the formats reviewed by standardization body to be sure that the format is fine. With the IETF, when we worked on having a standard about FFV1, for example, we found some bugs in the reference encoder. So it was good to have reviewers about that. And we create for that a big community, not only about the code, the FFV1 code, but also the users. And with that, we show that open source can also help about niche needs and not only broadcasting and the big things like YouTube and so on. It is finished, so if you have questions.
There was a question there who was first, yeah?
Yeah. So the main criticism was about speed encoding. So, but I had the question since before. So maybe the next version could be comparable to JPEG XS.
You mean maybe JPEG XL or there is a XS. Yes, exactly. Yes. How is it comparable to JPEG XS? So, if it is. There was some discussion between us and JPEG XS developers. So, JPEG XS is actually a bit based of FFV1. The developer took part of JPEG 2000 and also part of FFV1 for creating JPEG XS. So there was a path between, there is something from FFV1 actually in JPEG XS. JPEG XS is also open, but the specification is not open also. For FFV1, the specification at IETF, there is a copyright on it, and you cannot modify it, okay? But the version on our GitHub is totally open source also. It is a Creative Commons license. So also a big difference between FFV1 and JPEG XS is that FFV1 is easier to understand about the compression mechanism, and also that the specification license is open also. And for us, it is very important that everything is open, not only the compression and the decompression, but also the specification. But we need to do more performance comparison between speed or compression efficiency with JPEG XS, for sure.
just to continue on JPEG XS, there's also the issue that JPEG XS is not royalty free. So that also is a consideration, I think, that is important.
You need to repeat what you said.
Yeah, there is an issue about JPEG XS, about royalties. It is not completely sure about, there is some risk about patents, but the JPEG XS developers wanted that it is more or less free, so there is a discussion about that. But it is based on JPEG 2000, and there was some risk of patents with JPEG 2000 about the lossless part of JPEG 2000. So there is there is some risk about patents in the compression system. With FFV1, we are completely sure that there is no patent because we created nothing about that.
So I didn't really have a question, but I just want to thank the FFV1 project because it was I made a free lossless image format, FLIF, and it was quite inspired by FFV1 in the sense of the entropy coding and the context modeling that is going on there was inspired by FFV1. And now these things have moved from FLIF to JPEG XL, which is the other JPEG standard, where some of the context modeling of FFV1 actually is used in JPEG XL as well.
So the remark was about FFV1 helped to create FLIF and then JPEG XL. So it is part, FFV1 was, maybe I misunderstood. You talk about JPEG XS and I mix up with JPEG XL. I wanted to say about JPEG XL. So sorry about the confusion. So the names are confusing. So FFV1 was the base of JPEG XL, and now we need to do some comparison between what is FFV1 now and what if JPEG XL can help more than FFV1. But for the moment, it is pretty important for us to have open specifications and not behind the paywall. So with IETF, for us, it is very important to have that.
Yes, I agree that IETF is much better in that regard than ISO, which puts all the specifications behind the paywall, which is it's not helpful.
Yeah, one of the issues with JPEG XS or JPEG XL is the paywall.
Another question?
In comparison to raw video, what kind of compression ratio can someone expect?
The compression ratio is between 1 to 3, between half. The average is half. Sometimes it is a third, sometimes a bit more. So, but the average compression ratio is dividing by 2 the storage cost.
Is the algorithm itself extensible? If in the future, let's say you have a new compression algorithm that gets better ratios, can you switch that?
We could switch. FFV1 is based on the range coder for the moment, but if we find something better, we could switch. So and there is a discussion for FFV1 version 4 about what to use instead.
Is there a theoretical limit on how much you can divide the file based on the information of, for example, the video?
Is there a limit about the compression ratio? It is more that the content itself we need to avoid to lose a pixel. So if you have a black frame, it is very, very small. So the range coder you can store in 2 bytes. If it is only black, it will be repeated, and there is no bit consuming about that. But this is not a use case we have in reality.
How does the output file size compared with other codecs that use high quality parameters?
Compared to lossy compression, you mean? A lot. The files are, if you have a good quality, for example, Netflix, highest quality, You speak about maybe 20 or 30 megabits per second, and here with FFV1 for the same content, it is more 200 megabits per second. So it is very costly to store lossless content. You really need to have a lossless compression for paying for that, for sure. So it is not so fancy, and it is not something for the broadcasting, because the storage cost is very high for that. But some people need to store very losslessly things.
It's more about when you send it to the browser.
It is huge.
Yeah.
You need a huge bandwidth, for sure.
I have another question. Sorry to figure about the second question. Because it's for archival purposes, what happens if you miss a bit somewhere? What happens if there's an error somewhere?
In FFV1, there is a checksums. So every slice, the frame is cut in slice. You can have hundreds of slices if you want, and every slice has a checksum. So we can detect that a slice was corrupt during the storage. We have a tool which is able to rebuild the slice in error if there is one bit flip, for example. We can catch the bit flip thanks to the CRC. For more, we are working on having error correction codes. So, but it is not in FFV1, it is in Matroska. We want to expand Matroska container for storing the error correction code.
We are out of time. Thank you,
No,
Jerome.
welcome.